In today's example, we'll be using the two-way table. With the two-way table, responses are classified with two variables. So our first variable is blood type, and our other variable is Rh factor. So that's why this table is called a two-way table. A blood bank catalogs the types of blood, including positive or negative Rh factor, given by donors during the last 5 days. The number of donors who gave each blood type is listed in the following table. A donor is selected at random. So the questions we have are to find the probability that the donor has type O or type A. For part A, we're going to find the probability that the donor has type O or type A blood. The word OR indicates the union of these two events. Each of the blood types itself is an event. So we have event O, event A, event B, and event AB. The other events deal with the Rh factor. One event is positive Rh, the other is negative Rh. So we are looking for the probability that blood type O is in union with blood type A. So to calculate this, we're going to find blood type O, and that involves these values. And we have a total. 156 added to 28 makes the total of 184. The next blood type is A. So the event A would involve 139 plus 25 makes 164 total. So I'm taking the total of 184 blood type O, adding that to the total 164 have blood type A. That makes 348 out of a total of 409 possible. So here's the 409 possible samples. So 184 added to 164 makes 348 out of 409. And when we divide that, the probability is 0.851. So we are writing our probabilities in decimal form here. Sometimes you're going to see the probabilities as fractions and other times as decimals. So we'll just go ahead and simplify with a decimal. Part B is asking if the events mentioned in Part A are mutually exclusive. To be mutually exclusive, that means the events do not share any information. So there should be no intersection. So looking back at where I've circled the values for event O and event A, you can see that none of those values are overlapping. 156 is only in event O. 28 is also only in event O. 139 is only in event A, and 25 is only in event A. Since none of the measurements are shared, we do have mutually exclusive events. The events type O and type A are mutually exclusive because they do not intersect or they do not share any of their measurements. For part C, we're looking for the probability that the donor has type B blood or has Rh negative. So again, the word or indicates the union of these two events. So we're looking for the probability of type B in union with Rh negative. So we'll go back up to the table. This time I'll use red for event B. So here's type B blood, and then the other event is Rh negative. So this is going the other direction. And you'll notice here in red, the number 8 has been used more than one time. That value has been counted twice. So it's important that we don't count that twice. So we have a total of 45 for blood type B, and that's added to the total of 65 for negative Rh. But notice we're subtracting 8, and that was the intersection. So we need to be sure to subtract one of the values that got duplicated. That gives us a total of 102 out of 409, and we could write that in decimal form, 0.249. So don't forget that the probability of these two events was the probability of each event added to the other. Then we had to subtract the intersection of these events.